Having defined a random variable, it now makes sense to talk about a random variable's average or expected value. Formally, we define the expectation of a random variable x like this. We consider the set of values that x could take on, notating it as x of omega, the image of the sample space under x, and we sum over all these possible values, giving each a weight according to how probable the value is. Thus, the expectation is a weighted average of all the values that a variable could take on. For example, let the random variable x be the number of heads in 3 fair coin tosses. Then, according to this definition, this would be 0 times 1/8 for getting no heads, plus 1 times 3/8 for getting 1 head. There are 3 possible tosses that could have come up heads. Also, 2 times 3/8 for getting 2 heads. Similarly, there are 3 possible tosses that could have come up tails, so as to give us 2 heads. And lastly, there's only a 1/8 chance of getting all 3 heads. Adding these up, we get 12/8, or 3/2. Now, if I asked you casually, how many heads will there be in 3 coin tosses on average, you probably would have said 3/2 rather quickly, without doing all this calculation. Each toss should get you a half a head, so with 3, you should get 3 halves, you might have reasoned. In terms of our notation, we can express the argument like this. We let xi be 1 if the ith fair coin toss is heads, and we let it be 0 otherwise. Then, we say that the average number of heads in 3 tosses is the expectation of x1 plus x2 plus x3, and this is the expectation of x1 plus the expectation of x2 plus the expectation of x3, and this totals to 3/2. The key step in the proof is this equality here, which says that the expectation of the sum is the sum of the expectations. This is called the linearity of expectation, and as we will see, this turns out to be a very powerful idea. In general, for any 2 random variables x and y, and any constant a, we have these 2 equalities. The expectation of the sum is the sum of the expectations, and we can just factor out constant factors from expectations. Remember this theorem.